that to do this foraging, you actually have to suppress certain areas of the brain, like the cortex is really involved in self-control, like this, especially the frontal cortex. And so when you give fructose, you inhibit the activity of that area so that you have less self-control. It's sort of like alcohol, actually. But likewise, you'll if you give fructose, you'll inhibit the area for recent memory, because the recent memory is, you don't want to really have vivid memories of how dangerous it is, where you're going to go, right? And it will also like stimulate impulsivity and all these things. And the way it does it works on certain regions of the brain. And guess what? Those are the insulin-dependent regions of the brain. And certain areas of the brain it stimulates, like the anterior cingulate, for example, is a part of the brain that's important for foraging, and fructose stimulates that, but other areas it inhibits. And then when you look at that, you find this amazing thing. Alzheimer's affects the areas of the brain that are inhibited by fructose, and the areas that are stimulated by fructose are preserved. So like the occipital cortex, so that you can see the food, it's not affected very much in Alzheimer's. The anterior cingulate, which drives the foraging, that's not really affected in Alzheimer's. But the cerebral cortex, the hippocampus, the entorhinal cortex, all these different areas that are inhibited by fructose are actually the signature of where it occurs. And it's the same areas where insulin resistance occurs.